we're going to make AND gate out of NOR gate. Alright, let's start with our inputs. We have input A. I'm going to split it and then feed that input signal to a NOR gate. Then I have a B input, and I am likewise going to split it, the input signal, and feed that to a NOR gate. This is a pretty ugly looking NOR gate. Anyway, it works. The next thing I do is I feed this, two of these guys, their output, to another NOR gate. Now, let's get down to details. A feeds in here. With this node it splits, and the output is A ORed with A, quantity not. Down here, B is ORed with B, quantity not. Now these two come into this NOR gate over here, and the output becomes, first let's do this guy over here, A or A not, and that's going to be ORed with B or B not. Let's write that down, B or B not, and then it's going to be NORed, quantity NORed, and that's our final output. And what I'm saying is that this whole thing here is really an AND gate, and it's ANDing A and B. Now you say to me, but that doesn't look like an AND gate in any way, shape, or form to me. No, it doesn't. So we'll simplify it, and then we'll see that indeed it is an AND gate. Let's move down here, get some fighting room, and rewrite this A or A not, ORed with B or B not, quantity knotted. Alright, let's do the math on this. DeMorganize theorem says that this fellow over here, the quantity knot, it's over there, both of these terms. Because of that, we can split it here at the operator. Let's do that now. This becomes A or A, not, and this becomes B or B, not, and the OR inverts to its opposite, which is an AND. So now we have A or A double knotted, and a double knotted is going to disappear. So now we have A or A, and I'm going to AND that with two double knots, two double negatives disappear, so that's B or B. Let's move this up a bit. Now what do we do with this? Well, let's write an equivalent expression. Common factor here for this guy is A times what gives me A? Well, 1. Bring down the OR. A times what gives me this A? 1. So what do we have here now? We have a 1 or a 1. That's an OR gate. That's an OR gate. And we all know that if you OR a 1 with a 1, you're going to get an output of 1. So 1 or 1 is a 1. So A ANDed with 1. A ANDed with 1. There's A. There's a 1. If you AND anything with a 1, if A is a 0, you're going to get 0 and 1. That's a 0. If A is a 1, 1 and 1 is a 1. So if you AND 1 with anything, you're going to get that anything, which is to say, if you AND 1 with A, you're going to get A. So A ANDed with 1 will be A. It's that simple. Now let's concentrate on B or B. B or B, simplified just like the A, becomes B times 1 or 1. 1 ORed with a 1 is always a 1. So you get B ended with 1. Anything ended with a 1 will be whatever that anything is, which in this case is B. Let's bring down the and we've got our answer, which is A and B. So let's go back up to the top, and we can now see this guy here is actually A ended with B. And that's it. Thanks for listening. We'll see you in the next video. Bye-bye now.